Okay. I found the sample one in the textbook. It's like the table, and you
Hmm.
fill in the data for all the A through O protons.
Yes. Now that would be that's a good introductory level one. Have you tried any of those?
No.
Definitely.
So I
Once
can.
again, yeah, that's where you start. You don't go straight to the problems where you got to figure out the structure from the spectrum. Start with those because you're mimicking the machine. And if you can create the data the machine creates, then you understand what the machine's doing. That's my logic towards teaching it that way. And then in the next set of problems where you use that data going backwards to figure out what the structure is, that there's the true power of NMR.
Okay. So, oh, well, I may be thinking it's more simple than it is, but say I see a hydrogen attached to another alkyl group, which is attached to oxygen atom. I'm just going to assume if I'm worried about the methyl hydrogen, it just could be RCH3 is the one, the value I'm gonna be looking for.
Well, okay, I drew what you said. Let's finish what you were saying though. So I got that. You're saying
Oh,
that's a methyl up there now?
um, CH3, CH2O.
CH3, CH2, oops, H2O, like this? Mm-hmm.
It's more linear. It's
But
like straight.
does it really matter?
Oh, well, yeah, that's the same thing.
Yeah.
Yeah. Okay.
So what I would need to know though is what's on the other side of the O, because that will tell us where the
It's
heat
attached
will
to a
show.
benzene or a phenyl group.
Phenyl. Okay. That's basically an R group. And the important thing to notice here is that is an ether linkage. And let me quickly pull up the data table if I can. Uh, Sadly, I forgot to open our website. It's coming up. And still logging in. So you got to find the ether for these H's here. There are no H's down here, so there's no HC ether down here. And
Yeah,
that,
because it's
like
a
you
full
said,
octet.
this one is a normal methyl, so RCH3. You're looking
So if I was
somewhere between zero
concerned,
point 0.8 to 1.0, right?
right. So I don't have to worry much beyond that other carbon it's attached to.
No,
Just
no.
okay. Right.
Yeah, generally get it in the
Because
broad category first, and then inductive effects will have an effect. Like that O isn't that far away, right?
right.
So I would lean towards saying 1 instead of 0.8, but I'm not going to
Right.
grade that way. If you have it in the right category and it's only in one category, I'm going to you get full credit for anything in that range.
Right. I know they're very just they can be broad sometimes, so sometimes best to use like your best judgment or outside of
Yeah,
that.
some of the
I
ranges
know.
are quite broad, yes.
And just to be sure, those the chemical, I mean the protons on the methyl group
Right?
are chemically non-equivalent to the protons at the
Yeah.
adjacent carbon.
Yes, this is a totally different category. We're going to find that category. My computer's just asking me a lot of things here. All right. So, yeah, this category here, we'll put it in purple, is for these H's. R is attached to CH2, is attached to O, is attached to R. So, we're going to look that one up in the table, which I'll bring over here. And
So
table, might have to look at the,
with
there it is. So, the best
with a
match is here, isn't it?
oh yeah, okay, there you go. It's right there.
Yeah,
So
that's an ether, and the H is there. Now, if it was an ester, it's a different story, isn't it? Ester
yeah,
on the H attached to the C attached to the O, much bigger number. And so this is the one we want, 3.3 to 4.0, 3.3 to 4.0, 3.3 to 4.0. So what we would see, if you had to summarize these peaks in their entirety, you would say we'll see a peak at, say, the middle of that range. Middle of the range is 3.6.
6.
And why would it be a quartet? That's a separate question. Has nothing to do with being an ether. It has to do with the fact that next door on the vicinal carbon, there are 3 neighbors. 3 plus 1 is 4. The name of the pattern with 4 peaks in it is a quartet.
So you don't even, when determining whether it's say a quartet or it's a whatever.
It's just
multiplet
about the
it is,
neighbors. Don't even
It's
think
not
about
about
functional groups
theirs.
anymore. It's
It's
not,
not
no,
about-
it's not about
it's not
who
about
you
their
are.
hydrogens.
It's who your neighbors are and how many there are. Yeah, neighbors are defined as H's on a vicinal carbon. So how many neighbors does this H have? Well, this is not a carbon, so there's no neighbors here. There's a vicinal carbon with 3 neighbors. 3 plus 1 is 4, giving quartet. And the third question is, how big is the peak for these 2 identical hydrogens going to be? And the answer to that is 2. It's a relative height of 2. As opposed to this one here, the relative height, this will be the third data point, will be 3. So that's the easiest question to answer. How big will the peak be? Well, there's 3 H's contributing towards the peak. It will be a height of 3 compared to this, which will be a height of 2.
Right, I'm assuming we don't really get into the integration part of it, but
Well,
I
that
know,
is the integration. This number is the integration.
right,
yes.
because I read that, it was whatever the area under the curve is.
That's exactly it.
It gives you like the ratio of the hydrogens you're
But for us,
comparing.
it's how big is the peak? We just use those words instead of making it a math thing, right?
Right, yeah,
It is
I'd
a
rather
math
it
thing.
be that way.
It is a math thing. The computers can tell us integrations, right?
Right.
Back in the day when I was your age, though, they couldn't. We had to cut. Well, I didn't have to, but when NMR was in its nascent stage, they had to take the graph, cut the peak out, weigh the peak, and the mass was proportional to the integration. Weighing a piece of paper on a balance. Can you imagine that?
Yeah.
Nowadays, a
that's
computer can
kinda
do that
smart.
in a femtosecond for us, right? Now, the last question for the green one is, what is the pattern? Once again, neighbors. How many neighbors do these 3 H's have? Don't say 3. No.
2.
Neighbors, yes, 2. And what's 2 plus 1 is 3. We call
3.
that a triplet. So right there, we have a good little introductory segment video, I think. Do you mind if I post it? Because I think I used your first name in there.
You're fine. You can do that.
Okay. And I now have the editing ability. So that will help a lot of people as they start the exploration of NMR, I think.
So I haven't looked at the owl last time I mentioned it to you. I'm assuming you just kind of put